Okay, on to the concept of percentage by mass. Now, it's not strictly in the syllabus, but it's one of those concepts that pops up in chemistry quite a lot, in chemistry calculations. So, because it's so easy and it's so intuitive, we might as well include it here. It's a straightforward idea. So, what you do is you say how much of a particular compound is a specific element, how much of it by percentage is that particular element. So, let's have a look at calcium carbonate from the previous question. Now, we know that calcium carbonate is made up of calcium, one atom of calcium, one of carbon, and three of oxygen. So, what would be the percentage by mass of calcium? Well, to work that out, we need to use the relative atomic mass of calcium and divide that by the relative formula mass of calcium carbonate, the molar mass of calcium carbonate, if you like. 40 is the relative atomic mass of calcium, and we saw in the previous question that the molar mass for calcium carbonate was 100 grams, 100. So it's 40%. That makes complete sense. Now, if we add up all of the percentages of the different elements in a compound, the final total has to be 100%. So I'll let you go back and work out the percentage by mass of carbon and oxygen in this compound. The molar gas volume. This is another of those features that you have to learn off by heart to be able to do calculations in chemistry. So the idea here is, regardless of the kind of gas we're talking about, that 1 mole of any gas occupies 24 decimeter cubed at RTP. Now, a decimeter cubed is a new unit for you, potentially. And a decimeter cubed is the same as a litre. We'll talk about this in a minute. And there's 1,000 centimeter cubed in a decimeter cubed. RTP stands for room temperature and pressure. So 1 mole of oxygen, carbon dioxide, hydrogen, methane, sulfur dioxide, ozone, nitrogen dioxide, whatever you want to talk about, is going to occupy this volume. It takes a volume of 24 decimeter cubed at RTP. Now, RTP, let's be a bit more specific. Room temperature and pressure is given to be 20 degrees C and 100 kilopascals. Okay? Something to note is that obviously the volume is the same for 1 mole of a gas, but the mass in that particular volume is different. So 1 mole of hydrogen is 2 grams of hydrogen in 24 decimeter cubed. 1 mole of oxygen is 32 grams of oxygen in 24 decimeter cubed. Carbon dioxide, 44 grams in 24 decimeter cubed, which is important to get clear. The molar gas volume, sometimes called Avogadro's gas law or Avogadro's gas volume. Now, in calculations, some people like these triangles. So the moles of gas equals the volume of the gas divided by 24, or the volume of gas equals the number of moles of gas times 24, or you can just use simple ratios. I tend to prefer simple ratios and proportions. So let's have a look at this. What volume does 0.25 moles of any gas occupy at RTP? 1 mole occupies 24 decimeter cubed. So 0.25 moles would occupy 0.25 times 24 decimeter cubed equals 6 decimeter cubed. Now, just to note what we mentioned before, 1 decimeter cubed is 1 litre. A decimeter cubed is one of those strange units that chemists use to wind up the physicists. And in 1 decimeter cubed, there are 1,000 centimeter cubed. And we can combine this equation, the molar gas volume equation, and the moles equation in questions in chemistry. So, what volume will 1.6 grams of oxygen occupy? Well, the first step is to convert this mass into a number of moles of oxygen. Number of moles of oxygen would be the mass divided by its molar mass. 1.6 is what we've got, and the molar mass of oxygen is 2 times 16, 32, which works out to be 0.05 moles. Now we've got 0.05 moles, we need to find out what volume this number of moles will occupy. So if 1 mole occupies 24 decimeter cubed, 0.05 moles will occupy x decimeter cubed. Using simple ratios or using your triangle above, you can say x is going to be 0.05 times 24 divided by 1. I always use the idea that if we've got these set like this in this arrangement, then if I want x is going to be the diagonals multiplied together divided by what's opposite. That gives me 1.2 decimeter cubed, or, if you prefer, multiply by 1,000, 1,200 centimeter cubed. Okay, that's the idea. So you can practice these ideas a little bit more by reading the pages that are indicated and trying the questions.